So today we're gonna get to do some machine parts, which is interesting. They are laser cut on the outside contours. There's some inner parts also cut, and they have a little bit of a burr, of course, and then you have, from the machining itself, you have a burr, especially in here. There's some interesting corners in here, very, very tippy, sharp. And then over on the side, we have some 10 gauge stainless steel, very straightforward, clean cut. I put on the DM1100C, I put the regular standard aluminum oxide 40-60 mix. These are worn in by about 10%. They are 45 instead of 50 millimeters long, if you look across that. And they are already nicely broken in, which makes them a little bit softer at the tip, which I think is better for this kind of an application. We're gonna have to run both sides because some of the burr on some of these parts is actually also on the back side. But you have a nasty burr here on this side from the machining where the cutter went out. So this is fairly simple and straightforward in the application. I'm going to start with a 10 gauge. So this is very simple. This machine is already set to where it runs pretty well. And then we're just going to go to that thickness. 10 gauge, about 3.4. That's what they measure. There we go. We're going to turn the cross belt on, conveyor belt on. We're going to go about 30 inches per minute on those parts. And I don't think that we need to run further test. It has a very, very slight burr. That should come off just fine. We are going to orient those at a nice angle and let them go through. Like I say, they have a little bit of dross and some pearls here, but that should all come off fine. Then, this material here is 5/8 or 16 millimeter. Came out to be pretty much exactly 16 millimeters. This is half inch, about 12.6, 12.7. On this machine, it's not so critical that you get the thickness right, but of course, if you set it to a little bit lower, then you're going to brush a little bit harder, which we can in those materials because they're nice and thick. We won't be touching the conveyor belt. Here you see those coming out, and you can see the white line. That's your radius. You will be pleased, I think, with the result in that. And yeah. This one still has a little bit of a dross. I need to check why that didn't all come off. On the other ones it did. Maybe for that we need to go to a little bit more aggressive and also you see this little bit of splash that didn't come off. We need to go to a little bit more aggressive belt, which would be our ceramic belt that you see here. This is a red 50 grit with a purple Scotch-Brite in the middle, and then we have a 60 grit ceramic also, which probably would be better for what we are doing here. So now we're going to be moving on to the half-inch material. So for that, we set the machine to half-inch, and that's all we're going to have to do. I think I'm going to bring this down another 60 thousandths total. We were at 42.5 before, to get a little bit more aggressive on these parts. Like I said, we're going to run both the front and the back. Let's run one first and see what that does. And I'm also on these, I'm going to increase the speed to about 36 inches a minute, 3 feet per minute. The dial, the potentiometer on the machine does not indicate the feet per minute. just a 1 to 10 dial, and if it sits on 2, that means it is a 3 foot per minute, 1 foot per minute more than what the dial is. Now you see here the edges, and you also see I was worried about rounding that corner too much, but I think these are all very nice, exactly what you are looking for. And we are going to run the same thing on the back side here, where you have a little bit of a honeycomb. The machine doesn't remove anything from the surface, so you will still see the mill surface on that, the mill scale on that surface as it comes out. But it is much cleaner, and again you see the white line. That's your radius on the part. I think you will like that. Yeah, seems to be a good setting. So we have the comparison between deburred and not deburred. That would be that. So I'm just going to take these two, and again I'm going to reduce the speed just about 6 inches per minute, which is a lot of that. When you run 3 feet a minute, or if you run 30 inches a minute, that's almost 20%. That makes a difference. Actually, I had this running, not at full speed. That may make a difference. I think you will see a more aggressive result now. That's what we need to repeat for the 10 gauge. So now we do the same thing for the 5/8 material, which are those pieces, and we can run those pretty much in conjunction. So deposit this on the table here, bring this back down a little bit, and like I say here on the thickness, we will go to 16. That's the part we're going to a little bit how productive this is going to be. Do that in real life. Here we have a little bit of drop. Not sure that we can catch that. Again, this is an edge rounding machine, not necessarily a deburring. As the parts come out the back, right away bring those around again to the front. diagonal, so you get the best rounding effect. So now let's revisit. And by the way, on the side, of course, you cannot remove that. That you need to do by hand. But let's revisit the 10 gauge for a moment. This you will not be able to. That's on the surface. The machine is not designed to do that. But the little bit that we see here, I am very sure that we can get that quite a bit better. And we are going to go a little bit more aggressive into the belt as we had it. And we're going to slow, we are still at 30 inches a minute. Actually, I'm going to slow that down to 24 inches. And now you hear a different sound. Now we are going a little bit more aggressive at it. We are going to back that off just a tad. Half a mil. Not so heavy in the conveyor. Don't have to do that. Now you'll see a different result. Granted, this is the second pass, you need to keep that in mind, but I think you can already see what I mean by that difference. And you see that that little block on the side is completely gone. We only have that piece of weld spatter left. But other than that, it's good. There's more weld spatter here. If you want to remove this weld spatter, you first would have to belt sand these parts. Like that. And with the belt sander, you don't make the edges round. On the contrary, you make them very sharp. But you would remove that spatter on the surface because the belt sander is designed to remove material evenly from the surface and make a homogeneous, consistent surface. So this was one pass on the back side of those parts. That's of course the non-burr side, so you automatically will see more radius there. Because you have less material to remove in order to achieve that radius. run, you could put 1, 2, 3, 4, 5 parts side by side, and they would pass through the machine in about 8 inches. So at 30 inches a minute, you'd have at least 3 rows per minute. So you would run approximately 15 per minute or 900 per hour of these parts. Well, and that concludes our business here. I'll send those parts back to you. You did an excellent packaging job, probably the best one of my customers ever. And I appreciate you sending us parts. Always welcome. And we'll talk once you receive them back. Thank you very much.